Greetings everyone. Today we're going to continue to explore the operations with radicals, but specifically multiplying. Make sure if you are in my Algebra 1 class that you have this foldable ready to fill in. Things might look a little different here or there, just go with the flow. If you're not in my class, I would recommend maybe jotting these examples down somewhere in your notebook. All right, first of all, let's talk about the rules of multiplying in the top half of our notes. The first rule is, and this rule is a little bit easier than adding and subtracting, we can multiply any radicals as long as they have the same index. Index meaning what kind of root is it? Is it a squared root? Is it a cubed root? Is it a fourth root, etc.? Now, in our class, since this is algebra, we're going to stick to squared roots, but know that this will carry on and be needed for cubed and fourth roots in the coming years. The first step, if you will, if you were to sort of number these maybe as steps, the first thing is you want to multiply the numbers outside the radicals. If it's a regular number, treat it like a regular number. Secondly, I would encourage you to multiply the numbers under the radicals. Remember, those are called the radicands. And then thirdly, you need to simplify. You're likely going to have a radicand that breaks down. So phrases like reducing radicals, that's what I'm talking about here. Okay, so you want to reduce that radical as much as you can. All right, remember at any time if you need to pause, write down, re-listen, please make sure to do so. So example 1, same index, check. We're going to multiply the numbers outside. There are none. Step 2, multiply the radicands. That gets me to 9. Step 3, simplify. Square root of 9 is just 3, right? There's no radical. It's a perfect square. Notice the pattern. A radicand of 3, a radicand of 3 gets me just 3. You have to memorize that pattern? No, but you do have to understand it. Example 2, same index, no numbers out front. Multiply the numbers underneath. Reduce. Square root of 20. The largest perfect square that fits in would be 4. Square root of 4 is 2. Square root of 5 stays. 12 and 4. Now, you have a couple of approaches here. My eyes are drawn to this 4, you guys. That 4 is just 2. So let me rewrite the problem. Square root of 12 times 2, which means let's just throw that 2 out front. Oh, but then we still got to break down the 12. 12 breaks down to 4 and 3, right? Perfect square of 4, 3 remaining. Square root of 4 is 2. Now here's what's most forgotten. There was already a 2 out front. What do I do if I have two numbers next to each other? As always, you multiply them. Now, to be honest, I don't expect a lot of students to see that perfect square right away, so let me show you another approach. Another approach would be the same rules. Multiply the numbers out front, there are none. Multiply the numbers underneath. 12, 24, 36, 48. Okay, third step, break it down, simplify it. A perfect square that fits into 48 is 16 and 3. Let me rephrase that. The largest perfect square is 16. 16 goes down to 4, and square root of 3 stays. So again, if there happens to be something that could reduce sooner, do you have to? No, you don't. All right, example 4, same indexes. These will all be square roots, so let's just go with that. Multiply the numbers out front. That's a 1 and a 2, which gets me a 2. Multiply the numbers underneath, the radicands. That gets me 36. Break down. Wait a second, square root of 36. Square root of 36 is just 6. And then that 2's hanging out up front. Now these are next to each other. What do values next to each other mean in math? It means multiply. Our answer is 12. Now, I want to see this work. Do I understand there's ways to type it in your calculator? Yeah. But I need to see that you understand radicals. This is so important going into next year. And I just want to see that you're thinking it through, that you're not just copying from a machine. All right, next example, let's multiply the numbers out front. 2 times 4. Let's multiply the radicands, the numbers underneath. 12 times 15. Oh my goodness, we're going to have a big number. Now some students say, well, can't I break down the 12 first? Sure, but you know what? I'm just going to follow the same rules as we've been doing. I'm going to say 180. Well, let's break that down. We need to break down the square root of 180. What's the largest perfect square that fits in 180? 36. 36 fits in 5 times, and then that 8 is still there. All right, the 8 keeps falling down. Square root of 36 is just 6. Square root of 5 stays. Those two numbers are hanging out front together. So what do? We multiply them. 8 times 6 gets me a nice clean 48 out front, and the square root of 5 stays. Now let's take a look at this. Let's talk about, what does squared mean? Squared means a value times itself. Oh, square root of 7 times square root of 7 is square root of 49. Square root of 49, if we reduce it, it's just 7. You guys, we saw this in example 1. When you multiply like radicands, you get the radicand. Or, let's really shorten this up. Squaring and square rooting are opposite operations. They're, inverse operations. They undo each other. Squaring a square root cancels it out. That's something that's going to make things so much easier next year in geometry class. All right, I'm still going to show writing it out because I feel like that's important for you to understand. And so I'm going to start by rewriting this problem just like we did with multiplying binomials, right? I encouraged you to write them twice. So multiply the numbers out front. 2 times 2 is 4. Multiply the numbers underneath. 3 times 3, square root of 9. Square root of 9 is just 3. That 4 is hanging out. 4 times 3 is 12. Let's try the next one the same way. So are there a little bit shorter processes to this? Yes, but I want you to get in the habit of understanding what we're doing here. What we're doing is we're squaring. This is power of a product, so you can distribute. We're distributing or squaring the negative 3. Negative 3 times negative 3 is positive 9. Oh, negative 3 squared is 9. And then we're taking square root of 3 times square root of 3. That's square root of 9, which is just 3. The 9's hanging out, so we get a 27. Square root of 3 squared is just 3. 9 times 3 is 27. So I'm showing every little step of work on that one. Could you shorten it up if you memorize? Sure thing. Another way we might multiply, look at example 9, you guys. Let's go back to distributing. We are just distributing onto 2 chunks of information. 2 times 2 is 4. 2 times square root of 3 is 2 square root of 3, right? I can't multiply a constant times a radicand. I can't. So I just have a number on the outside and a number on the inside. I also cannot add these because they don't have common radicals. So that's all I can do. The next 3 examples, I needed a little more space, so I'm not showing them all at once. So that's why you just see one of them. But let's work on distributing. Square root of 3 times 3. Well, I can't do anything about it. And it's more appropriate to write the integer out front. Okay. Oh, I don't know why my pen does that. Let me fix that. Let's distribute again. Square root of 3 times square root of 6. Oh, we can deal with that. That's square root of 18. Those are radicands, right? Let's deal with that. But I got to break that down. Square root of 18 goes down to 9 and 2. The largest perfect square is 9. Square root of 9 is 3. And let's drop down that left side. Now let's talk about this. Can I add those? Based on our previous lesson, I can't. We can only add or subtract like radicands. It's kind of like we can only add or subtract like variables. We can only add or subtract like terms, right? To add or subtract, something needs to be the same, and this isn't the same radicand. Whoa, what's going on here? I have 2 chunks of information times 2 chunks of information. What does that look like? That looks like a binomial times a binomial. Now we would call this a complex number, but what that means is I need to double distribute, right? I see distribution, but I have 2 of them, so I'm going to double distribute. We're going back to our polynomials lesson. If you need help with that, check out multiplying polynomials lesson. All right, let's start with the 3. 3 times 3, that's 9. Let's go again. 3 times negative 4 square root of 3, negative 12 square root of 3, right? We multiply the numbers outside and, well, there's no other radicand, so it just stays. All right, let's go again. Let's distribute the second piece. Positive square root of 3 times 3 is positive 3 square root of 3. Can't even do anything, right? Slow down a little bit here. 3 times negative 4 square root of 3. All right, first of all, it's going to be a negative. 1 times 4 is 4. Square root of 3 times square root of 3 is square root of 9. Now, in the next step, I'm going to show 2 things at once. First of all, I have like terms right there. Actually, let me take that box and draw it around the sign as well. These are like terms. We can combine them. If I have negative 12 apples and I add 3 apples, I have negative 9 apples. If you need help with that, see my adding video. All right. Now, I'm just going to drop down that 9 that was hanging out front. Let's deal with this right side over here. Square root of 9 is 3. 4 times 3 is 12. Okay, well, guess what? We're still not done. Because look at this, I got regular old numbers. 9 minus 12 is negative 3. And then this weird radical number just stays. There's nothing I can do about it. So I'm just going to write 9 square root of 3. So remember, if it's 2 by 2, I should have 4 pieces in the beginning. And then those 4 pieces could possibly combine, could possibly reduce. All right, last one, 2 pieces times 2 pieces. So I should have 4 pieces. Okay, 2 times 2 is 4. So let me show this. Here's where if you do have colored crayons or pens, maybe consider color coordinating like I am, okay? Pause if you need to. First distribution. Square root of 2 times square root of 3 is square root of 6. Okay, let's distribute it again. Square root of 2 times square root of 6. Well, first of all, that's a positive times a negative, so it's negative. 2 times 6 is 12. Those are radicands, so they can be multiplied. All right, let's look at the next piece. Positive square root of 3 times positive square root of 3, positive square root of 9. Now, some of you are going to be like, Morphet, that's just 3. I memorized this already. Perfect. Then jot down a 3. I still need to see your 4 pieces of information, so let's keep going. Square root of 3 times square root of 6. Now, careful. Positive times negative is a negative. 3 times 6, 18. Now, at first glance, none of these combine, but some of them reduce. So let's start with 6. 6 does not have anything that breaks down, so it's just going to stay. And you know what? I'm just going to kind of go down 2 lines, 2 spaces, and I'm going to prep that. Square root of 12 does break down. Goes down to 4, 3, right? Square root of 4 is 2. Square root of 3 stays, so negative 2, square root of 3. Square root of 9. Well, some of you already thought that's just 3. Square root of 18. Square root of 18 breaks down. Perfect square that fits in is 9. It fits in twice. If you're having trouble reducing radicals, go re-listen to the reducing radicals video. Square root of 9 is 3. So 3 square roots of 2, and it was a negative. I still have 4 chunks of information, but a 6, a 3, and a 2 don't have anything in common. So guess what? We're going to leave it this way. So you're going to be uncomfortable with this because it looks messy. It's a lot of information, but sometimes a lot combines, like example 11, and sometimes barely anything. Awesome. Now, a couple of suggestions now that you've made it to the end of this little lesson. Please make sure to consider re-listening. You guys, it's hard to get everything when you're writing and listening and reading and probably have something else going on. So consider just re-listen to this, right? Without any writing, without any distractions. I promise you it'll help. Second of all, make sure to check Google Classroom, see what tasks you have at hand, see what practice. There's so many options for practicing this online, so seek out other resources if you need it, okay? Let me know if you have any questions, and until next time, have a good one.